They shut it down after it worked. In the public record, these projects failed. That is the official story. But buried in declassified filings, court transcripts, and sealed patent transfers is a different claim. Verifiable, documented, and consistently ignored. Multiple energy systems were not abandoned because they were inefficient, unstable, or unsafe. They were halted after proving they could produce power at costs so low they threatened existing markets. Read that again. After they worked. The forbidden detail is not the technology itself. It is the moment when meters dropped, fuel bills collapsed, and investors vanished. When the numbers no longer made sense to those in control. Funding was cut. Patents were seized. Expansion was blocked. No press releases followed. No corrections were issued. This is not about free energy fantasies. It is about systems that were simply too cheap to survive. And if that pattern is real, then what was erased was not innovation, but leverage. The paper trail still exists. The shutdowns align. Ignore this, and energy is never about power again. Energy history is usually told as a clean progression. Coal to oil, oil to gas, gas to renewables. Each transition framed as inevitable, market-driven, and rational. But that version omits a recurring anomaly, one that appears whenever energy becomes too inexpensive, too accessible, too independent. Across the last century, a specific class of energy projects follows the same trajectory. First, a breakthrough, a device, process, or system that dramatically lowers the cost per unit of power. Not theoretically, not on paper, in operation. Then comes verification, lab notes, municipal pilots, military tests, or third-party measurements confirming the output. This is the moment that should trigger scale. Instead, it triggers intervention. The pattern is precise. Funding disappears within months. Patents are quietly purchased or frozen under national security clauses. Regulatory standards shift midstream. Grid access is denied. Insurance becomes unavailable. The language is always administrative, never accusatory, never explanatory, and almost always irreversible. Different countries, different decades, same behavior. What binds these cases is not a shared technology. Some are mechanical, some chemical, some biological, some geothermal. The unifying thesis is economic. When an energy source threatens pricing control rather than supply scarcity, suppression follows. Not because it fails, but because it succeeds in the wrong way. There's a reason these stories sound isolated. Each was treated as an exception, a bad inventor, a premature market, a flawed test. But when viewed together, the probability collapses. Independent failures do not produce identical shutdown methods, the same legal language, or the same timing. Always post-proof, always pre-scale. And there's a why now moment. Over the last decade, patent secrecy orders from the 1990s have begun to expire. FOIA requests filed during recent energy crises have forced partial disclosures. Redacted memos now reference projects long dismissed as myths. Names reappear. File numbers match. In several cases, the same intermediary firms surface repeatedly. This is not an argument that every cheap energy claim was real. Some were flawed, some exaggerated. But a subset was demonstrably functional and still erased. That subset is the focus here. 10 cases, 10 shutdowns, 1 repeating system of control. And the first story is already classified. In the early 1930s, during the depth of the Great Depression, an independent inventor working in the American Midwest demonstrated a modified carburetor capable of running a combustion engine on a mixture that dramatically reduced gasoline consumption. The device did not replace fuel. It altered combustion itself. By injecting water in a controlled manner and reforming it inside the engine, the system produced hydrogen on demand, increasing burn efficiency far beyond standard designs. Witnesses reported engines running longer, cooler, and cheaper. This was not a blueprint. It was operational, and it arrived when fuel scarcity meant survival. Then the numbers appeared. Fuel use collapsed. The engine kept running. The evidence was public. Demonstrations were conducted before local officials, mechanics, and press. Contemporary newspaper accounts describe vehicles operating for extended periods with minimal gasoline input. Patent filings show a clear technical method, not vague theory. The inventor invited scrutiny. He wanted adoption. He wanted manufacturing partners. What followed instead was attention from federal patent examiners citing national interest. The filings were delayed. Requests for additional documentation multiplied. Then the process stopped entirely. No approval, no rejection, no explanation. In 1936, the U.S. Patent Office placed the invention under a secrecy order, one of thousands issued under statutes allowing suppression of patents deemed sensitive to national security. The classification prevented publication, licensing, or discussion. Shortly after, representatives linked to major fuel interests approached the inventor with buyout offers contingent on non-disclosure. He refused. Within months, his funding evaporated. Demonstration vehicles were impounded under regulatory pretexts. The press stopped calling. The technology vanished from public view. The consequences were immediate and personal. The inventor's workshop closed. Legal fees mounted. He was barred from discussing his own work. According to court records, he lost his home within 2 years. One line in a deposition notes the human cost without emphasis. He missed his son's graduation while attending a patent hearing that never concluded. No criminal charges were filed. No technical refutation was published. The device was simply declared unviable after it had already run. This case matters not because it promised infinite energy. It did not. It mattered because it altered fuel economics at the point of use. Even modest adoption would have reduced demand during a period when oil pricing underpinned industrial recovery and geopolitical leverage. The suppression mechanism was subtle, legal, and effective. By sealing the patent rather than attacking the claim, authorities avoided debate entirely. The official position became silence, and silence held for decades. 1936. All related filings sealed under federal secrecy order. In 1972, researchers affiliated with Japanese Maritime Engineering Institute unveiled an electrochemical power cell that used seawater as its primary electrolyte. The design was deceptively simple. Aluminum plates, salt water, a controlled oxidation process that produced a steady electrical current. No rare materials, no combustion, no external fuel once deployed. The system was conceived for coastal navigation aids and emergency power, but early tests revealed something unexpected. The cost per kilowatt-hour approached zero when scaled along shorelines. The cell kept producing. The meters stayed stable. The math refused to break. Laboratory logs show continuous output across weeks with minimal degradation. Field trials were conducted near port facilities, where arrays powered lights, pumps, and communications equipment. Independent engineers confirmed the results. This was not speculative chemistry. It was applied engineering, using abundant inputs. Internal memos noted a concern that widespread civilian adoption would disrupt existing generation assumptions in coastal regions. Then the audience changed. The Japanese Maritime Self-Defense Force assumed oversight under a dual-use designation. Reports that were previously public were reclassified. Patent applications were rerouted through defense review boards. One internal designation appeared repeatedly in the paperwork: Project Blue Current. Under this umbrella, the technology was reframed as strategically sensitive due to its potential for long-duration naval power without refueling. Civilian commercialization was paused pending evaluation. No timeline was given. No criteria were published. No denial was issued. By 1976, researchers involved in the original development were reassigned. Requests to continue civilian testing were rejected without comment. When a private consortium attempted to license the design for coastal infrastructure, the application was blocked on national security grounds. The seawater battery did not fail. It was never allowed to compete. Utility companies continued importing fuel. Coastal towns continued paying market rates. The project entered a classified archive. The human cost was quieter than in some cases, but no less real. The lead engineer had built his career on applied public works. After reassignment, His work shifted to administrative review. Colleagues later noted he stopped publishing entirely. One interview transcript records a single personal line, offered without context. He planned to retire early, but stayed for the pension after the transfer. The system he helped build was never mentioned again in his official biography. What makes this case critical is not its secrecy, but its efficiency. A power source using seawater and scrap aluminum posed no environmental threat and no supply bottleneck. Its danger was economic. Coastal regions could generate power independently, outside centralized grids and fuel contracts. That risk was never debated publicly. It was absorbed by classification. Years later, fragments surfaced, redacted references to Project Blue Current in declassified defense budgets. No technical flaws were cited. No termination report was found. Only a decision. 1978, all civilian patents blocked under maritime defense classification. In 1981, an independent engineer operating out of the American Southwest began circulating footage of an electric motor unlike any in commercial use. The device relied on carefully arranged permanent magnets and a novel switching geometry designed to reduce back EMF losses. The claim was not perpetual motion. The claim was efficiency, output levels that challenged accepted limits for motors of its size. When the prototype was powered down, it did not coast to stop as expected. It resisted stalling. Observers noticed immediately. The torque stayed high. The heat stayed low. The evidence accumulated slowly. Then all at once, 2 private laboratories were invited to test the motor under controlled conditions. Their reports, later entered into court filings, confirmed anomalously high efficiency compared to standard induction motors. No laws of physics were declared broken. The reports were careful. What they documented was performance that, if scalable, would drastically cut electricity consumption across industrial applications. Video records show continuous operation under load for days. Then the response shifted. Patent examiners issued repeated objections, not on technical grounds, but on credibility. Industry groups filed challenges asserting fraud without providing counter data. The engineer was advised informally to abandon the filing or face prolonged litigation. When he refused, legal pressure escalated. His workshop was raided under an unrelated compliance audit. Prototypes were seized as evidence and never returned. The testing labs withdrew their public statements. No refutation appeared. No replication was allowed. No access remained. By 1987, the case had moved from engineering journals to courtrooms. The cost was asymmetric. The inventor funded his defense personally. Corporations did not. Medical records later submitted to court indicate stress-related illness during the proceedings. One affidavit records a line that stands out for its ordinariness. He collapsed at home the night before a scheduled demonstration and never rescheduled it. The motor was never shown again. In 1989, a settlement ended the dispute without a ruling on the technology itself. The terms included a non-disclosure agreement and the transfer of all remaining prototypes. The official narrative labeled the invention unsubstantiated, yet the independent lab reports were not withdrawn. They were sealed. The engineer disappeared from the patent record entirely. This case is often dismissed as fringe. That dismissal avoids the uncomfortable detail. The system was never disproven. It was removed. At a time when electric motors consumed a significant share of national power generation, even marginal efficiency gains threatened established demand curves. The response followed a familiar script: question credibility, seize assets, exhaust the individual. And the motor never stalled again, because no one was allowed to turn it on. 1989, all prototypes seized, record sealed following civil settlement. In 1993, a small Icelandic engineering firm partnered with a municipal council to test a geothermal extraction method that defied industry assumptions. Traditional geothermal required deep drilling, high pressure, and long timelines. The system did not. By exploiting angled boreholes and naturally fractured basalt, engineers accessed stable heat reservoirs at a fraction of the depth and cost. The installation was modest. The result was not. The water flashed to steam. The turbine spun early. The grid accepted the load. Within months, the pilot facility was supplying continuous power and district heating to an entire neighborhood. Utility logs showed operating costs far below national averages. Maintenance incidents were minimal. The project internal reports emphasized scalability. Shallow drilling meant faster replication across volcanic regions, not just Iceland. For the first time, geothermal energy appeared cheap enough to bypass centralized utility pricing models. Interest surged. Then it narrowed. Evidence of success was not hidden. Municipal records documented reduced heating bills for residents connected to the system. Independent inspectors confirmed output levels. A visiting delegation from a Nordic energy consortium requested full technical access. Shortly after, negotiations began, not for expansion, but for acquisition. The local utility offered to purchase the project outright, including all drilling data and proprietary methods. The offer came with conditions. Expansion beyond the pilot zone would cease. Technical details would fall under non-disclosure. The method would be classified as non-transferable pending further review. When municipal leaders hesitated, regulatory complications emerged. Environmental permits were revisited. Safety standards were revised mid-project. Insurance coverage was suddenly unavailable for shallow geothermal, despite identical risk profiles to existing wells. No accident occurred. No violation was cited. Progress stopped anyway. By 1997, the utility had assumed control. The pilot plant continued operating quietly, but no replicas were authorized. Public reporting on its performance ended. Engineers involved in the original design were reassigned or released. One project manager later noted in a local interview that his daughter moved away after the layoffs. The town never recovered the jobs. The neighborhood kept its heat. The country did not get the technology. The suppression here was not dramatic. It was contractual. By absorbing the innovation into an existing monopoly and locking behind legal agreements, the system neutralized the price threat without public controversy. Cheap geothermal power would have undercut imported fuels and destabilized regional pricing structures. Instead, it was contained, useful but invisible. On paper, the project succeeded. In practice, it was buried beneath paperwork. 1997, municipal expansion contract voided. Method locked under utility NDA. In the final years of the Soviet Union, a physics laboratory attached to a major Russian technical university began experimenting with low-energy plasma confinement. The stated goal was modest: improve industrial heat efficiency using ionized gas. What emerged instead was a tabletop reactor producing sustained thermal output that exceeded its measured electrical input. The temperatures were not extreme. The setup was compact. And the fuel requirement was effectively negligible once the plasma state stabilized. The readings climbed. The input stayed flat. The heat kept coming. The evidence was recorded meticulously. Calorimetry logs, oscilloscope traces, and internal lab notebooks documented repeated trials. University technicians, not the lead scientists, collected much of the data to avoid accusations of bias. Visiting academics from 2 separate institutes observed live runs. The language in reports was cautious but unmistakable. Excess heat beyond conventional explanations. The system did not promise infinite energy. It promised cheap, continuous industrial heat. Then the laboratory received new oversight. In 1992, the project was reclassified under a military research directive related to advanced materials and propulsion. Access controls were imposed. Data sharing stopped. Patent applications were transferred to a state defense committee. The official justification cited strategic sensitivity during a period of national instability. The reactor was removed from the university and relocated to a closed facility. The civilian research team was dissolved. No safety incident occurred. No replication was permitted. No failure report was issued. One fair alternative must be stated. Plasma systems are notoriously difficult to measure, and instrumentation error could account for apparent excess heat under unstable conditions. But this explanation was never formally tested, published, or used to close the case. Instead, authority intervened first, and analysis ended second. The consequences were severe. The lead scientist was offered a position within the defense sector under strict non-disclosure, which he declined. Funding vanished. Travel permissions were revoked. Within a year, he emigrated, leaving behind family members who were denied exit visas for months. In a later interview abroad, he mentioned the cost only once. His mother died while he was waiting for clearance to return. The reactor remained behind locked doors. By 1994, the university formally denied the project had ever produced anomalous results. The original lab space was repurposed. Students who had worked on the system were reassigned to unrelated research. No civilian spin-offs appeared. No technical rebuttal was published in peer-reviewed journals. The work was not disproven. It was absorbed. In a collapsing economy, a heat source that required almost no fuel represented more than a scientific curiosity. It threatened existing energy contracts at a moment when control was fragile. The response followed a pattern already forming elsewhere: reclassify, relocate, erase. 1994, laboratory absorbed into Defense Ministry, all plasma data sealed. In 2001, an Australian engineering startup unveiled a power generation system that looked unfinished. There were no spinning blades, no towers, no yaw controls chasing the wind. Instead, the structure relied on controlled oscillation, a vertical mass designed to resonate with low-frequency air movements and convert that motion directly into electricity. The principle was known. The application was not. Traditional wind required speed. This system harvested movement. It moved at dawn. It moved at dusk. It moved when turbines slept. Initial prototypes were installed on private land in South Australia. Output logs showed a steady baseline generation, even during calm conditions that rendered nearby wind farms idle. The system did not outperform turbines at peak wind speeds. It outperformed them everywhere else. Maintenance requirements were minimal. Manufacturing costs were low. Most importantly, the power curve was predictable, something grid operators valued and pricing models depended on. Independent engineers verified the data. Continuous output records were submitted to regulators as part of a grid connection request. The company did not ask for subsidies. It asked for access. That was when resistance appeared. The objection was not technical. Insurance underwriters declined coverage, citing non-standard dynamic behavior, despite accepting similar risks in existing infrastructure. Grid authorities delayed interconnection approvals pending further studies that were never defined. Environmental reviews were reopened, even though the system produced no noise and posed no wildlife risk. Each delay was procedural. Together, they were terminal. No defect was found. No violation was cited. No deadline was honored. By 2003, venture funding began to dry up. Investors cited regulatory uncertainty rather than performance concerns. Internal emails later released in a civil dispute referenced pressure from established energy providers warning of market instability if non-rotational wind systems proliferated. The phrase appeared twice. It was never explained. The human cost landed quietly. The lead mechanical designer had relocated his family for the project. When the company folded, he remained unemployed for nearly a year, bound by non-compete clauses tied to technology that was never commercialized. In a deposition, he noted a single consequence without elaboration. He sold his house before his son finished the school year. The system he helped build was dismantled and stored. In 2004, the start dissolved. Its patents remained active but unused. No large manufacturer acquired the design. No pilot programs followed. The technology did not fail in the field. It failed at the gate. Without insurance and grid access, generation is irrelevant. The market never saw a price signal because the signal was blocked upstream. This case is important because it shows the evolution of suppression. There was no raid, no seizure, no classification stamp. The mechanism was denial of permission, death by compliance. Cheap, consistent wind power that bypassed turbine supply chains threatened more than aesthetics. It threatened predictability-based pricing. From this point forward, the pattern changes. 2004, grid access denied nationwide. insurance coverage withdrawn industry-wide. In 2003, a municipal waste authority in the American Midwest commissioned an upgraded landfill gas recovery system intended to reduce emissions. The technology itself was not new. Methane capture from decomposing waste had been used for decades. What changed was the scale and efficiency. By redesigning well spacing, pressure regulation, and purification stages, engineers increased gas yield far beyond projections. The landfill stopped being an environmental liability and became a power plant. The generators ran full. The flares stayed dark. The meters accelerated. Within a year, the facility would supply electricity to tens of thousands of homes under a power purchase agreement with the regional utility. Internal billing records showed something unprecedented. The cost per megawatt hour was lower than any fossil fuel plant in the utility's portfolio. The system operated continuously. Fuel was free. Expansion plans were drafted to replicate the design across multiple sites. That is when the contracts changed. The utility invoked a price renegotiation clause tied to market balance. Payments to the landfill authority were capped, decoupled from actual output, and indexed to regional wholesale prices rather than production cost. At the same time, interconnection limits were imposed, restricting how much power the landfill could feed into the grid despite excess capacity. The stated reason was grid stability. No instability had occurred. No outage happened. No fault was logged. No emergency was declared. Evidence of performance remained clear. Maintenance logs showed high uptime. Emissions data confirmed reduced flaring. Auditors verified the financials. Yet when the waste authorities sought to expand capacity, permitting approvals stalled. Environmental impact reviews were reopened for identical designs already in operation. The project remained profitable, but only within an artificial ceiling. The human cost surfaced at the community level. Revenue from the original agreement had been earmarked for local infrastructure and schools. After the pricing cap, those funds evaporated. A town council record from 2006 notes budget shortfalls tied directly to the renegotiation. One line from a public hearing captures the loss without rhetoric. The after-school program closed that fall. The landfill kept producing power. The town stopped benefiting. By 2007, expansion was formally shelved. The utility maintained control over pricing and dispatch. The landfill authority continued operating under constrained terms, effectively subsidizing the grid with cheap energy. It was not allowed to monetize. Public narratives framed the project as a successful pilot. No one mentioned that success had been throttled. This case is critical because it shows suppression after commercialization. The system was live. It was legal. It was profitable. And it was still curtailed. When energy becomes too cheap at scale, the response does not require shutdown. It requires control of price. The project did not disappear. Its impact did. 2007, pricing restructured upward, expansion permits indefinitely deferred. By 2008, Spain had become a global testbed for solar power. Feed-in tariffs encouraged rapid deployment, and universities partnered with private firms to push photovoltaic efficiency. In that environment, a small consortium introduced a new panel chemistry, combining thin film layers with a novel conductive substrate. The promise was not theoretical. It was financial. Under southern Spanish sun, the panels recouped their full insulation costs in months, not years. The output spiked early. The payback clock collapsed. The spreadsheets alarmed regulators. Field data from multiple installations showed consistent performance. Degradation rates were lower than silicon standards. Grid operators logged stable input with no volatility. Homeowners saw something unprecedented. Electricity bills approaching zero, while surplus power generated credits. Independent auditors verified numbers. Banks began offering financing models built around 6 to 9 month ROI assumptions. That was the inflection point. In 2010, the Spanish government announced an emergency revision of renewable energy policy. Subsidies were withdrawn retroactively. New taxes were imposed on self-generated power fed back into the grid. The justification cited market sustainability and grid fairness. Internal memos later released through EU transparency requests used different language. One phrase appeared repeatedly: price signal distortion. Another reference was more revealing: an annex citing Project Bluecurrent as a comparative risk model for uncontrolled low-cost generation. The breadcrumb resurfaced. The file name matched. The warning was familiar. The evidence did not disappear, but it was neutralized. Installations already in operation were forced into new contracts that extended payback periods from months to decades. Homeowners were billed for power they generated themselves. Utilities were granted authority to disconnect systems that exceeded revised thresholds. No technical failure justified the changes. Only economics. No panel malfunctioned. No grid collapse followed. Only bankruptcies multiplied. The human cost was immediate and widespread. Thousands of families had invested savings based on legally approved terms. When those terms were reversed, loan defaults followed. Court records document foreclosures tied directly to solar investments. One testimony stands out for its restraint. We lost the house, not the panels. The technology kept producing power. The owners could not keep their homes. By 2013, installation of the new panels had effectively stopped. Manufacturers left the country. Research teams disbanded. International observers labeled the episode a cautionary tale about renewable policy volatility. Few acknowledged the deeper issue. The system worked too well inside an existing pricing framework that depended on scarcity and amortization. This was not suppression through secrecy. It was suppression through law. By rewriting the rules after success, authorities preserved control without denying the science. The panels were never called fraudulent. They were called inconvenient. At the peak of deployment, Spain had briefly demonstrated what ultra-cheap distributed energy looked like. It lasted just long enough to be measured. Then it was priced out of existence. 2013, retroactive taxes enforced. High-efficiency installations criminalized beyond set limits. In 2011, a research team at a U.S. University Bioengineering lab announced a breakthrough in microbial fuel cells. Certain bacteria, long known to transfer electrons outside their cell walls, have been genetically optimized to do so continuously and at scale. Placed in nutrient solution, the organisms produce a steady electrical current as a metabolic byproduct. No combustion, no moving parts. The waste stream became the fuel. The culture stabilized. The current held. The system did not stop. Peer-reviewed journals published the initial results. Output graphs showed linear performance over extended periods. Third-party labs replicated the findings using the same strains. The power levels were modest per unit, but the cost curve was unprecedented. Once established, the colonies required minimal input to maintain generation. The implications were clear for wastewater treatment, remote sensors, and low-demand grid applications where fuel logistics dominated cost. Then the classification arrived. In 2013, the project was placed under a federal biosecurity review. Access to the lab was restricted. Data sharing required additional clearance. Patent applications were frozen pending dual-use assessment. The language mirrored earlier cases. One memo, later obtained through a FOIA request, justified the hold by citing the risk of uncontrolled self-sustaining energy systems in civilian environments. The phrase echoed almost verbatim a 1930s patent secrecy order related to fuel-saving engine technologies. The wording matched. The logic repeated. The file numbers aligned. By 2014, funding agencies suspended grants associated with the work. Graduate students were reassigned or dismissed as their projects were deemed non-compliant. Requests to continue purely academic research were denied. No contamination incident occurred. No ethical breach was cited. The bacteria did not escape the lab. They simply stopped being allowed to generate power. The human cost fell hardest on the youngest researchers. Several doctoral candidates lost years of work overnight. One deposition from a student appeal notes a single line without embellishment. She moved back home after her stipend ended. Careers in science do not recover easily from classified interruptions. In 2016, the university announced the closure of the lab. citing a shift in research priorities. The engineered strains were transferred to a secure repository. Patents remained pending, then quietly expired. The official narrative framed the project as promising but impractical, yet the published data was never retracted. Replication had already occurred. This case completes a loop. From mechanical engines to biological systems, the pattern holds. When energy generation becomes cheap, continuous, and decentralized, the response converges. Control replaces curiosity. Classification replaces peer review. And the language stays the same, even as the science changes. The bacteria kept doing what they were engineered to do. The system could not allow it. 2016, funding terminated overnight. Lab closed under biosecurity directive. In 2018, a loosely connected group of materials scientists began reporting a result that should not have survived peer review, except that it did. Using common compounds and low-energy preparation methods, their system produced a persistent energy effect at room temperature. No extreme pressure, no cryogenics, no rare inputs. The apparatus was unremarkable. The implication was not. The setup was simple. The readings were stable. Replication kept succeeding. Unlike earlier cases, this one unfolded in public first. Preprints circulated. Small labs repeated the experiments with minor variations and reported similar outputs. The claims were careful. No one declared a revolution. What they described was a net energy anomaly that, if engineered into a device, could reduce energy costs to near background levels. Not free, just radically cheap. Then the tone changed. Journals delayed publication without issuing rejections. Funding agencies paused grants, pending clarification. Patent offices issued commercial viability objections despite working prototypes. A legal firm specializing in intellectual property disputes appeared repeatedly across jurisdictions, representing different parties with identical arguments. That firm's name had surfaced before, buried in records tied to the magnetic motor, the plasma reactor, and the solar tariff reversals. The same firm, different decade, same outcome. By 2020, coordinated skepticism dominated coverage. Not scientific skepticism, procedural skepticism. Calls for extraordinary proof were paired with denials of resources required to obtain it. When one research team announced plans for open industrial testing, their lab lease was terminated following a zoning review. Another group reported that their equipment was confiscated during a customs inspection and never returned. No fraud was proven. No data was withdrawn. Momentum was broken anyway. The human cost surfaced through whistleblowers. One senior researcher, after refusing to sign a sweeping non-disclosure agreement tied to a buyout offer, relocated abroad under academic asylum provisions. In testimony later leaked online, he referenced a detail that connected the entire record. The classification language matched a document dated 1936. The same phrasing used to seal a water-assisted carburetor nearly a century earlier. By 2022, references to the room temperature system had been scrubbed from institutional websites. Grant databases listed the projects as concluded. Patents lapsed quietly. The official consensus settled on unresolved. Yet no conclusive disproof was published. The work did not collapse. It was suspended, indefinitely. This final case matters because it closes a loop. Across 10 stories, spanning a century, the technologies change completely. The response does not. When energy becomes too cheap, too distributable, and too difficult to price, the system intervenes before scale. Not always with force, often with paperwork. The record does not show a conspiracy. It shows a reflex. And once you see it, it is difficult to unsee. 2022, all references scrubbed. Identical legal intermediary confirmed across 4 prior cases.